All right. Well, first of all, thank you all for joining us today for our webinar on XDR for OT environments. Just as an initial introduction, there's three of us with you here today. I'm John Livingston. I'm the CEO of Verve. I've been with the company for about 5 years or so. Prior to that, I spent about 20 years of my career with a consulting firm called McKinsey & Company, helping clients with their overall digital transformation efforts in the industrial environment. Also joining us today is Rick Kaun, who's our VP of Solutions, and he's been doing this for about 20 years in the industrial control security space. And then also with us is Ryan Zahn. Ryan is going to actually demonstrate a little bit of how this works in practice. He's our Director of Customer Success, and he has about 15 years as an ICS security engineer. Prior to that, he was an EMS engineer in the power industry. Just by way of background for those of you who aren't familiar with Verve, where do we come at this topic or this question? So Verve's been around for almost 30 years. We started our life as an industrial controls engineering firm, helping clients design reliable and secure industrial control systems. About 15 years ago, we started to develop the Verve Security Center to help clients secure their OT or ICS environments from risks and threats from internal and external threats. The idea of what Verve does is to try to bring the best of IT security into the OT world. We like to say, to know what you can do in an OT world to secure it, not just what you cannot do. And XDR is one of those topics as we've been pushing further and further in our conversations with clients and their needs and how one might protect these systems. XDR becomes a pretty interesting way of securing the environments. We also provide a range of managed services because we strongly believe that this is a man and machine kind of thing, that true automated response where there's no human involved in OT is a very risky thing to do. And so our view is to help our clients with some of those managed services as they go forward. So that's kind of a bit of background of us and how we approach this whole topic. So what's our agenda for today? So we're going to talk a little bit about what is the threat landscape and how is it changing? And particularly what we've referred to as air raid, the various dynamics that are driving changes in OT security. We're then going to talk about the challenges with kind of the status quo of how to go at securing these environments, which is either manually or often thought of as network anomaly detection, and why that's a challenging and limited a way to go at it. And then we're going to talk a little bit more about this XDR approach, about how you can go at securing OT systems, taking a full view of both the risks and the threats within the concept of X detection and response, sort of multi-dimensional detection and response to risks and threats. So to start with, how do we think about these attacks and the threats? And so we've tended to think about this as three broad categories of risks into the ICS world. The first is what we call collateral damage, where OT is not the target of that attack, but it is impacted as collateral damage. These can be where the threat or the ransomware in this case spreads into the OT environment, as it did at Merck and Maersk and a number of those during the NotPetya period of time. Or it can be things like the Colonial Pipeline, where the attack stopped from all public reports in IT. The problem was that there was no visibility of where it could spread if it got across that OT barrier. And so due to payment systems and a lack of appropriate segmentation, et cetera, they essentially had to stop production. And so OT became quote unquote collateral damage of that attack. Those types of risks tend to be more likely, like we're seeing a lot more of those. The risks, obviously Colonial was a huge one, but the risk to life and limb may be less than some of these other risks we talk about. So the targeted non-advanced attack, something like the Oldsmar water attack, where it was not very advanced. The attacker used TeamViewer. It was very quickly recognized because the settings that they put in to the chemicals into the water treatment facility were so far out of line that the control system essentially caught it and saw that they were out of line. Obviously, if that had worked, there would have been a substantial impact, and the severity would have been substantial. Then finally are the things that, frankly, a lot of people get excited about and focused on, rightfully so, which are advanced outsiders or an insider, an advanced insider. But typically, these are the APTs, the state-sponsored type attacks, which can be quite significant from a severity point of view. I mean, Trisis, if it had actually worked, would have had substantial physical, if not human damage. Stuxnet obviously had significant damage, but these are also less likely, right? Because you need to have advanced skills to use these kinds of tools, et cetera, et cetera. And so we tend to think about this because OT practitioners, security practitioners, need to think about protecting against all these different kinds of risks, not just focused on, okay, all I have to do is detect, potentially that APT. No, actually, we have to think about what do we do in the world of collateral damage, which frankly is likely to be more likely than some of these other attacks. And so the security environment, those risks are starting to change and change quickly. So there's a set of challenges that organizations have, everything from having visibility, fixing foundational elements of security like patching and cleaning up users and accounts that shouldn't be there, and removing software like TeamViewer that shouldn't be on the systems, et cetera. They need to do things like managing third-party risks of remote access, et cetera. And all of those are core current challenges. But what's happening here, really been accelerating in the last 18 to 24 months, is what we call air raid. So first of all, attackers are changing. Not only are they becoming more brazen, but we're also moving into a world where the commercial hackers are starting to look at industrial operations as a very profitable enterprise. Because ransomware can be so profitable, if I can shut down your manufacturing facilities for a period of time, that number of those collateral damage type attacks, or attacks where it may be more advanced, but it's specifically focused on ransomware, start to go up. Secondly, IT. So there has been a significant shift in the past 18 months to IT taking responsibility and ownership for the OT security challenge. And as a result of that, trying to leverage tools that they have, consolidate information, et cetera. That is changing the way that OT security risks are addressed. Regulation. If we look at this recent, in the United States, the TSA regulation, the pipeline regulations that just came out, we are starting to see this look more and more like a NERC type regulatory, NERC SIP type regulatory environment, meaning having very prescriptive requirements for pipeline operators of things they have to do, and also to be able to demonstrate those things. NERC SIP has been a hotly debated topic, whether it's been cost benefit positive, but there is no question that there has been a significant investment in improving the compliance anyway with security requirements. That regulatory environment seems to be moving beyond the North American power sector. Outside of the US, in Latin America, Brazil and Chile have just adopted things like that. The Middle East is adopting similar types of standards. And now with the TSA pipeline, it's moving from power into pipelines. Resource constraints. The resource constraints are only getting worse. As the number of vulnerabilities grow, it's literally becoming overwhelming for the OT security teams just to keep pace with all of what's out there from a vulnerability point of view. Alert fatigue. As more people start to monitor these systems, the number of alerts are increasing, which is requiring more incident response and again, putting a burden on the teams that are supposed to be doing this. Insurers, the I for insurers. So ICS is now all of a sudden a central focus of the insurance industry. If you look over the last maybe 10 years, as cyber insurance evolved, it was not a very quote unquote hard market. It was a soft market, meaning it wasn't priced significantly high to buy cybersecurity insurance. Because of the recent events over the past 18 to 24 months, those cybersecurity prices have been going up and the market has been quote unquote hardening. As a result of that, insurers are now looking at the broader set of risks, including OT risks, and coming to organizations saying, hey, what's your security posture in OT? And so that's creating a new set of requirements for operators. And then finally, directors. Directors are looking for measurable improvement. Hey, we've been doing this with our personal information for years. Okay, how are we going to demonstrate that same kind of metrics within the OT environment? So all these changes, really it's been about the last 18 months that these have started to hit. And our view is that they are going to accelerate over the next 3 to 4 years. And that's going to start to shift some of the OT or ICS security requirements. We're going to have to move from just looking at these known threats. Okay, I have a signature for Trisis. Yeah, I can see that. But you know what? They're not going to use that same signature again. So how do I stop the things I haven't seen before? How do I stop the noise? How do I reduce the number of alerts that I'm getting down to things that are really relevant on really relevant systems? How do I start to integrate with IT tools and consolidate the number of tools I have? I can't use 15 different tools. I've got to find a way to consolidate those. How do I demonstrate progress? So it's not enough just to, okay, great, I now have a detection tool in there and I'm detecting a bunch of things. But am I actually getting better? Am I showing demonstrable improvement in my security posture? And then finally, from a services point of view, there is going to be a significant need in our view for risk services to support teams as the number of these threats and risks go up at the same time as the demands from regulations and insurers go up. So this is the context in which we begin this discussion around XDR. Just as history, there have been obviously a number of OT attacks over time. This is a representative sample before basically February or March of this year. But just in the last 6 months or so, we have seen an explosion of new attacks in the OT environment. Molson Coors, WestRock, Colonial Pipeline, JBS Meats, and on and on and on. And this was done in June. The number goes on and on from there. We are seeing an ever increasing number of attacks in the OT environment. At the same time that that's happening, the known risks in the environment are exploding. So this has changed from the end of 2019 to the end of 2020. An increase in CVEs within the ICS environments by roughly 50%. And the scores, the risk scores of those vulnerabilities up by about 40%. We can debate whether CVSS is a perfect way of scoring these or not, but overall a higher risk per vulnerability and a lot more vulnerabilities, which is this problem of being overwhelmed, right? Of, oh my God, now I've got more and more vulnerabilities. And now we're talking about, we're gonna do software bill of materials. We're gonna blow up the bomb on all of that embedded software. And what's hiding in there is going to be more and more and more vulnerabilities. So what's happening? Well, now manufacturing and energy are the two most have gone from essentially eighth and ninth in targets to being second and third. So the OT world, manufacturing, energy, things like that, are now becoming kind of the hotspot for attacks in 2020. And the idea is to target companies that may have insurance, but also who have a significant downside if those threats, if their manufacturing operations are stopped, and therefore they're willing to pay up from a ransomware point of view. And that just, this chart of how many days have been lost by some of these recent events, these are a significant number of days of manufacturing. right? Even if I lose a day, it could be $100,000, it could be $1 million, depending on what it is. And when you start to add up, 10, 20, 30, 60, 100 days lost, the dollars start to increase dramatically. And so the focus of getting this right and starting to protect these systems is absolutely critical. So if that's the problem, that's what that's what we got to solve. Well, our view is that the way we've been approaching this today, which is essentially a purely detection-based approach using network approaches, is just not enough. So, the challenges, we all know the challenges. My guess is most of the people on this webinar are familiar with the OT or ICS security challenges. So I won't spend a lot of time on these things, right? But, to not have AD infrastructure in place, for instance, to have OEM managed systems, all of these things on the left-hand side create a challenging problem to secure these environments. And so what we need to have is we need to be able to do specific asset inventory and vulnerability management. We need to consolidate to reduce the resource risk, the resource requirements, because the resources are being constrained. We need to have real-time data about changes in the asset, in the endpoint, not just the data in the network, et cetera. And so we're going to have to find a way to deal with these challenges. And detection alone to do that just isn't enough. The traditional approach is, of passive network monitoring. So we monitor for anomalies. From an endpoint point of view, we may be monitoring those things manually. We have Excel spreadsheets. Maybe we have a scan that we do once a year to do a vulnerability scan on those devices because we can't scan them regularly because we can possibly trip off and brick certain devices. A lack of remediation or visibility into compensating control. So, okay, maybe I can't patch that thing, but is there some compensating control that I could put on it? But we have limited telemetry. So we're basically focused on just the network telemetry. So, what about all these other forms of telemetry like logs and endpoint detection information and firewall logs, et cetera? And so what do we need? We need to address both the risks of these environments as well as the threats. By risks, we mean the starting point, right? What is my fundamental risk? But also then, okay, I got to understand what are the threats that are taking advantage of those risks. We need to integrate a more comprehensive telemetry, and then we need to integrate response to provide that kind of XDR capability. So, as I mentioned, risk and threats. So on the risk side, before we go anywhere, we've got to recognize that in whatever we do, we have to realize that these systems are quote unquote insecure by design, insecure by neglect. We can call them whatever we want, but basically we've got things like shared passwords. We've got dormant accounts. We've got old systems like XP or Windows 2000 or Windows 7. We've got sensitive embedded devices down there. We've got dual home NICs. So wonderful, we've got a firewall, but then we've got 3 systems, servers that have dual NICs. So they're going around that firewall so that I can have remote access because the vendor needs remote access. I've got tons and tons of patches that are needed, but unapproved by the vendor or haven't been deployed yet. The starting point for our security journey in OT starts with a set of starting risks that we have to recognize and we have to deal with before we move on, before we start doing detections, and before we start thinking about threats. We got to deal with the risks. And when we think about those risks, and we said before that we think the network only approach kind of falls down. Well, it falls down because I don't know those risks. So yeah, I know it's a Windows box from looking at the traffic, but I don't know the patches that have been deployed. I know it's an OS version, but that doesn't tell me exactly what the patches that have been deployed. I don't know the policies on that device. I don't know the users and accounts. I don't know what applications are running on that device unless they happen to be communicating over the wire, et cetera. And then even if I do, I can't do anything. I can't patch the system. I can't harden a config. I can't remove that user that shouldn't be there. I then have to go in manually and do those exercises. And on the detection front, all I've got is network traffic to do the detections. And so there's a fundamental gap in this approach in our view. And then when we move from those risks that we mentioned to the threats, to how to detect an actual threat that's occurring, we actually thought the recent evaluation on the ICS MITRE attack framework was quite interesting. This is Dale Peterson's comments on it. But the fact that all 5 products that were evaluated detected the attack, in some ways it wasn't that hard, right? It was pretty obvious set of attacks. But importantly, just looking at the network traffic wasn't really good enough, right? Having the Windows logs would have been really helpful. Having OT firewall logs or endpoint detection logs would have been additional help in detecting any threats. And then querying PLCs directly, actively querying the PLCs to pull back information from those PLCs to know what was going on. Essentially, additional forms of telemetry could have been very beneficial. When we think about that, this is when we start to say there's got to be a way to think about XDR, meaning bringing in a broader set of telemetry, not just networks, to respond to these threats. So how do we do that? How do we bring risk management or risk reduction and threat detection and response together to improve our starting point, demonstrate success, as well as to detect and respond to ongoing threats? So when we say XDR, what do we mean by that? It's a very subjective term, probably. So the X is multiple dimensions, right? And the DR is detection and response. So multi-dimensional detection and response. That to us means integrating telemetry from multiple sources. It also means integrating the response with all of the availability of all of the information available from the endpoints, et cetera. And that improves the detection and response with better insights on the threats and how to respond, which is really beneficial in OT. And so the reason we're so focused on both risk and threat is if all I'm doing is trying to detect threats, by the way, with only one form of telemetry, network data, I don't know the risks. And so I can see a detection, but I don't know how can I solve that? How can I stop that threat from happening by reducing the risk in my environment? In other words, can I patch it? Can I change a configuration setting? Can I remove a user? It's a pass the hash attack and it's being by a particular user. Can I just eliminate those users on these accounts? By bringing that risk picture and the detection picture together, I can start to build a true response plan that makes sense in what we think of as the least disruptive response possible, or LDR. So what would that look like in OT? Well, it would look like risk reduction. So it would look like knowing what those environmental factors are that could create a chance of an event. They're flat networks, unpatched vulnerabilities, dormant accounts. So these are things that an attacker can take advantage of and then reduce those risks. So, okay, let's remove those accounts and users. Let's remove software that shouldn't be there. Let's harden the configurations on those networking devices, et cetera. But it would also include threat response. So what is a threat? A threat is an active behavior that could cause impact, typically by taking advantage of one of those risks on the left-hand side of this page. But then importantly, it's also the response. Detecting, so identifying a real threat, investigating it. What is the depth of that threat? In other words, where could it go? What could it do? Planning for the least disruptive response to that threat. But then taking that action, being able to immediately go in with a human, in our view, intermediating it, but basically saying, look, we can think, okay, this is what's happening in the environment and we should take this action. But that action is then controlled by a human user before triggering the action. But it would have, XDR and OT would have both of these capabilities so that we can reduce the amount of risk we have and then respond to the threat in the least disruptive way possible. So where does it start? Well, it starts, you cannot do this without having a risk view of every asset in your environment, because that is what tells us where the threat could spread or where it could start. And number two, what we can start to do right away before the threat exists to remediate those risks. That includes vulnerabilities, patches, configurations, users' accounts, et cetera. And by looking at that 360-degree view, I can prioritize my resources against those risks that are greatest. And I can start to resolve insecure by design assets. I can stop the spread of threats by modeling where those threats may move if they happen, because I have that full picture, right? We think a lot about, people talk a lot about doing red teaming or pen testing of OT environments. So pen testing OT is a challenging thing to do in any level of depth because of the risk to operations that it could cause. By having this risk view, you can run lots of pen tests, lots of scenarios of what could an attacker do given the risks in the environment. To do that right, you've got to start with really deep endpoint visibility. You got to get all the way down to that asset. You got to be able to see what installed software is there, what's the patch status, what are the password settings. The only way to get this right is to get that deep view. So that's the risk side, identifying those risks, knowing what could go wrong, et cetera. But then XDR also requires a wide range of telemetry. That's what the X is about. Right? We got to be able to bring in as many different forms of telemetry as possible. syslog, netflow, configuration changes on the device, to Dale's point about querying the PLC, device metrics. Are we seeing a spike in CPU usage? Windows logs themselves, user behavior, file creation, et cetera. Firewall logs, so perimeter NIDS type firewall logs. AV or whitelisting and other process creation logs. Deep packet inspection or interior NIDS. And then because we're in OT, because we are actually operating a physical process, well, let's bring in the physical process alarms, because at the end of the day, that's what we're worried about disrupting. And so all of those different forms of telemetry should come into an XDR platform. And then the detection elements use all of that data in an integrated way from a manual point of view to discover and visualize threats, but most importantly, from an automated way. So to be able to do anomaly detection across those different dimensions so that we can see when different anomalies are happening, but also by having that data to reduce the false positives because we're starting to correlate across the systems. And then obviously rule-based detections, things like ICS, like MITRE ATT&CK for ICS, where we can create signature type-based detections as well. But the XDR really needs to include all of those different forms of telemetry and integrate that with the risk picture that we talked about before. And so, that kind of threat detection would see monitoring of overviews of overall detections, but it would tie into MITRE ATT&CK framework. It would integrate industrial process alarms. We'd have pre-built rules to look for possible ransomware type events. We'd have canaries, meaning small files that we put on each endpoint, that if those files are accessed for any reason, we send off an alert because we know that that file is not used for anything other than being a canary for a ransomware event. These are the kinds of things that we would be able to do by having all of that data into a single platform. But at the end of the day, threat detection isn't worth much if we can't respond. And so the XDR platform also has to enable us to be able to respond quickly to a threat. We need to be able to detect it, analyze the time series of what's happening, do the incident response, review user and endpoint data to see what's actually happening and frankly, where that could spread the attack path. And then develop a planned procedure, but then to be able to pull the trigger and actually execute remediation actions. Again, we're not suggesting that this would be an automated detection and response. We truly believe in the need for a human interaction here, but the ability to use that tool to have all that data in one place and say, yes, we need to remove the user across these 6 devices, that user across these 6 devices. We need to close the following port across these 10 devices. We need to shut down these 3 devices. We need to patch certain vulnerabilities. all of those types of actions are required for us to be able to quickly respond. And the idea that what we're going to do is to say, oh, we detected something, now we'll call the plant, and somebody in the plant will try and figure out what they can do to respond. It just takes too long. We are going to have to get to the point where we can see the threat, know the risks of that environment, and immediately move to a response to being able to take the least disruptive response that we can. And so our view is we need to integrate that risk picture and the threat picture into the same platform. And so what we've built with Verve is it all starts with an asset inventory, but then that asset inventory gives us a risk picture. It tells us the vulnerabilities, it tells us the patch status, it tells us configurations, it tells us users and accounts, software, et cetera. But then similarly, it also includes the threat detection piece, the malware detections, the intrusion detection from all that telemetry we talked about, as well as the incident response, the ability to see that threat happening and then be able to take action on that threat. Our view is that we are going to need a single platform to do this, from just a labor point of view, but most importantly, from a XDR, from the detection and response point of view, to have that data in one place so we can pivot around it to respond as quickly as we possibly can. Obviously, that XDR kind of platform needs to fit into the broader IT security platform. We talked about IT being a key part of the decision-making and the responsibility now for OT security. Whatever we do within the OT security world has to fit within the IT security architecture. ServiceNow or whatever CMDB you're using, it needs to fit in with an enterprise SIEM, whether it be Splunk or QRadar or Elastic or whatever. It needs to be able to integrate things like firewall logs from the IT, the perimeter firewall logs, et cetera. All of those components need to be able to fit easily. And so this platform has to have very robust APIs and integrations with those IT tools so that we can move data in and out seamlessly. So what would that look like, therefore, in practice? Well, you would start with the risk side, and you'd be able to identify and eliminate things like dormant accounts or passwords that are set poorly. We'd identify and remediate those dual home NICs. We'd ensure backups are up to date. We'd identify those critical vulnerabilities, and we'd start to patch things that we could, or if we couldn't patch them, we'd make sure that there were compensating controls like whitelisting enabled and things like that. But then we'd also be doing the threat response. So we'd be deploying and monitoring canaries. We'd monitor for anomalous file access. We'd alert on communication between established microsegments, et cetera. And those two pieces would come together to be able to give us both risk reduction as well as threat response in an integrated way. To do that, we need to then bring this XDR system has to be able to get that data up to a scaled analysis. We need to have people at the top who can look at that data centrally across sites to be able to analyze it. The power industry has pushed to actually do this across enterprises, where they're going to try and have sanitized data on detections across enterprises, which is great, but we better also have the risk data, because having a bunch of detections without the risk data doesn't really help us all that much. But in any event, scaling that analysis, scaling that up so I can reduce the number of people who I need to train. Also, I can improve my detections because I'm gathering more data from more locations. But then those response actions need to happen locally. We are not suggesting that you want to start patching systems on a generation plant from 2,000 miles away, or you want to start removing users. We need to be able to design the threat detection, design the risk reduction, and the response centrally, but then have those actions taken locally. So essentially be able to distribute the action and then have the local person who understands that operation be able to take that response action as quickly as they can in a safe manner. And it's going to require more than just outsourced SIEM. In the IT world, MSSPs have built essentially outsourced SIEMs, outsourced SOCs, et cetera, which are all good. There's nothing wrong with that. Unfortunately, in OT, we're going to have to build more than that, because in IT, there's a level of expectation on IT systems management. Things are basically patched. Things are, users and accounts are managed well, et cetera, et cetera. In the OT world, we're going to have to do both of those things. So a true XDR solution is going to have to include things like risk roadmaps. It's going to have to include vulnerability assessments and manage patch deployment, as well as the more traditional MSSP detection and response capabilities. Because we have to think, as I said before, we have to think about risk and threat together at the same time. So what is the advantage of that approach? Well, we get better risk management because we get a complete view, we get a 360-degree view of the asset. Number two, it's comprehensive protection, not just detection. So we're talking about that risk reduction, not just threat detection. It's a better detection because we're using all these different forms of telemetry, the X part of this. It also has the response part, right? It's not just detection, but it is response, because I can integrate that detection with a specific response action. It's scalable. I don't have to put, tons of taps in, no hidden deployment costs. That platform operations where we're aggregating all that data to the top dramatically reduces the labor cost of managing OT security management. And then finally, it's OT safe. It's the idea of doing the best in breed IT security, but with a man in the middle, meaning there's a human interaction before that action is taken that ensures that we don't trip the plant or something in the process of trying to secure it. So that is our basic description of this. What I thought we'd do now is let Ryan talk a little bit about how this actually looks in practice. We're just going to share 5 minutes or so of how that kind of appears within a product. So Ryan, I'll stop sharing and hand it over to you for a few minutes.
Great. Thanks, John. Let me get my screen shared out here. Oh, I actually have to click share after that. I clicked on it, but it didn't share it out. All right. Hopefully everybody's able to see my screen now. So just to run through some of the detections in here, specifically focused around John's original use case about ransomware events. And so I do have some interesting information around process creation, as well as canary file modification. So part of the platform is deploying these pretty much empty files in unused locations on endpoints, and then looking for them to be modified so that we can use that with pretty decent certainty that there is some type of ransomware event encrypting files. So just looking through here, you'll actually notice there is a canary file modified event that is occurring right here in this event. So I can actually go dig into that and actually click this little filter here, and we can see what endpoint that it was on, and that is a high risk and critical severity type event. And so this would be something that would warrant some type of alert, so we could figure out how to investigate as well as remediate and maybe even isolate that endpoint from the rest of the environment so it doesn't spread. Now, again, not every ransomware is self-proliferating, so there are some that do and some that don't. And so it's just being able to try to limit its available paths is also very useful. So that could be using the actioning part to reach out, maybe logically disconnect that asset from the network. So it wouldn't be a good demo without actually showing you what a timeline looks like with these types of ransomware events. And so I'm going to pull up quickly one of these ransomware investigation timelines. And so this is a part of a platform that lets us group log messages together so that we can go back and investigate and add notes. You'll actually see here at the very top, I've actually removed the message, but this is actually where the canary file is being modified on an asset. And so if we pull up the full event, we could actually go through and look for the attribute that mentions that this file has been modified. And you can see there's actually the file name right there for that particular incident. Just to kind of run through the actual rest of the timeline and what you would actually see in a potential ransomware event. So we would actually see some new processes being created, some runtime embedding. And then actually, as we go through and look at the rest of the process arguments, you'll notice that, doing things like turning off the firewall on the endpoint, trying to retrieve information, and even embedding the particular, in this case, garbageware ransomware into a service, and then being able to reference that later. And so this just shows that typical timeline approach to where we can go and look for these types of events occurring not only on one asset, but maybe multiple assets or an entire network, to really dig in and try to figure out how far spread this type of event is. And also adding notes to your investigation. So as you saw here, actually I clicked the wrong button again, but if I were to expand this, we can look at any notes or add additional notes to specific events so that we can keep track of and who is tracking and investigating these types of this type of or exploit. So how do you go about remediation? And so I do want to bring up a quick dashboard. So one of there's actually two tactics you can use specifically in ransomware. And one of them is the best approach, which is don't let it happen in the first place. So have some type of compensating controls in place. So maybe things like application whitelisting or some type of hardening or network segmentation so it can't spread, those types of things. But also having good backups of your assets, right? So if you were to ever have some type of widespread or even localized ransomware event, you could easily know that your backups are recent, they are good backups, and that we can quickly restore and get back up on our feet rather than having to try to rebuild everything from the ground up again, which could cost millions as well as significant amount of time that's involved as well. Just to add to, if there was a type of ransomware that was spreading throughout the environment, one of the things that also is collected and that's really good to look at in the investigation process is network flow data. So information around network connections and what's talking and where specific packets are coming from and going to, because this can allow you to do two things, right? We can create events to say, hey, if there's a new IP address, that's communicating to this asset we've never seen before, well, obviously that's a red flag because, if there was already an event, then we know that something from the outside is trying to get in, but also trying to see new connections internally to see if there's some type of spread of either access, through the exploitation or of just the actual ransomware itself, if it is self-proliferating. So being able to have that is very useful. Now, really the key and the anchor to all of this type of information is having a full 100% asset inventory that covers every asset in your environment, because you can't protect things that you're not aware of or that you don't know the profile of. And so being able to have a full asset inventory, knowing locations and what type of function it serves in your controls environment, the manufacturers of those assets, even, operating system or firmware information, even the zones it sits in or how critical it is to your process are all very important key metrics that really drive that remediation strategy once a ransomware event has occurred in your environment. All right, John, I think that's just about everything for me. We could open it up for questions. I know we are a little early, but.
Oh, thank you, Ryan. Appreciate it.
No problem.
Appreciate it. And maybe I'll go back and just quickly share one more screen here. So we had some questions that came in advance of the webinar. And so what I thought we'd do is address some of those. Can you all see that screen, Ryan, now?
Not yet. I see your face.
Okay, good. I'll share the screen.
Which is just as good.
So there were a couple of questions that were asked earlier in the day that we can address, and then I think there may be some more questions that are coming in here. If you do have some, please enter them in the Q&A. So first one was, how do you detect this without access to layer 3 switches? So what if you've got an environment that you don't have layer 3 switches and you can't gather flows or packets from those? I think one of the advantages of this approach is by aggregating different types of data, we're not dependent on just looking at packets. So if you've got layer 2 switching or you've got unmanaged switches, et cetera, This approach will gather all of the endpoint detection information. It'll gather whitelisting information off of the endpoints. It'll gather configuration changes off those end devices because we're going directly to the endpoint to get that information. And in fact, we often find that customers are struggling when they're using a network-only approach in those kinds of environments, which we find a lot of in the OT world. Another question was around standards for different industries. What we have seen, if we go back in time, there have been a series of surveys that have been done over the last 5 or 6 years. And historically, NIST CSF has been the primary winner, so to speak, in terms of the number of people and what frameworks they say they're using. And CIS Top 20 has usually been the second of those. What's happened over the last couple of years is IEC 62443 has become a much more prevalent or popular, depending on how you think about it, standard, particularly outside the United States. And so there's been a recent study this year, I think SAN survey, and it's just about to come out. Our expectation is that IEC 62443 will likely become a much move up on that list as we go. Obviously, everyone has to build their own particular set of standards that they want to use. Obviously, if you're in a geography that has a regulatory requirement and an industry with regulatory requirements, those will come into play. A question here is how is the Verve OT-XDR deployed within an ICS environment? And so Verve is deployed through essentially 3 components. So there's an agent component that would work on all of the HMIs, workstation server type devices, which has been proven on pretty much every brand of OT equipment. Then there's an agentless component. And what that means is the ability to reach out within the native protocol to all of those devices and query those devices to gather back configurations of switches and PLCs and relays and that sort of thing. And then the third is gathering logs and other forms of telemetry. And that's through both logging as well as a whole number of integrations with things like OSI Pi and other types of process alarm information, integrations with AV tools, integrations with whitelisting tools, so we can gather a lot more of that telemetry into the platform. How many protocols, the question is how many protocols and OT devices can OT detect? Can our XDR detect? Hundreds is the answer to that. As I mentioned, we're not, the way we're doing this is we're actually reaching out to those devices directly. And so we can detect that they exist, that's easy. It's the ability to go out and communicate with them and gather back their firmware and configurations. And that's where Verve kind of stands out, is our ability to reach out to those devices in their native protocols. And it's literally in the hundreds or thousands of different device types that we can reach out to. And then if necessary, we can build new drivers pretty quickly, somewhere between 2 and 4 weeks to build new drivers. One of the other questions was some of the best practices. So our view is, so the question was, explain operating system and network security best practices. So that's probably 3 webinars in and of itself. But our view is that those best practices come back to this risk and threat concept, right? Best practices in reducing risks, meaning getting visibility, being able to identify those risks and then over time reduce those risks. And at the same time, from a threat detection point of view, gathering data and doing threat detection and response. There's a question around, can you do this fully automated? Meaning, automated response without a human checking it. Our strong view is for the most part of the OT world, there will need to be a human involved in that final response step. Technically, it can be done, not a problem. You can absolutely do it automated. Our view is from a safety point of view and avoiding of things like type 2 errors, where you shut off a system that shouldn't be shut off, or you try and patch something that shouldn't be patched, et cetera, that there should be a human involved, and likely someone who has deep control systems experience with someone who has security experience before that action is taken. One of the questions in the chat was, do you need to install client software on endpoints? So yes, we do deploy client software on endpoints. That client software is about the size of your calculator app. So it's very, very small and sends very, very limited information. And importantly, is outbound only. So there is no need for having inbound ports that could screw up the your Purdue models and other types of network segmentation challenges. And then the question is, do we partner with any DCS providers? We have ongoing conversations. We don't have any announced partnerships. We have close relationships with many of them, but we do not have formal partnerships or quote unquote certification of those agents. But we have close relationships with many of the DCS vendors. And we have many client references where the system has been operating for years with no impact. One of the other questions was, what do we do about outdated devices? So many of our systems have, what was it, Windows XP or Windows 2000 and things like that, and what can we do in those cases? The great news is that this approach we've built specifically for control systems. And so it works completely fine on Windows XP and goes way back. And so whether it be the threat detection side, the application whitelisting, all the risk management, so everything from detecting of users and accounts and current patches that are not deployed, or dual NICs and all of that sort of thing, all can work equally well on Windows, XP and 7, et cetera, as it does on the latest and greatest. I think those are the main questions. So with that, I don't think there's any more questions. We're ending a couple minutes before the hour. We'd like to welcome you to our next webinar. So in about a month, we're going to be doing another webinar. One of the big topics that's come up as we've been talking to clients is essentially developing a strategy. So forget the technology for a second. Forget, Verve's platform and all the rest of that. How do we define overall objectives for an OT cybersecurity strategy? What are the tactics that we should be thinking about? Like the question today, what are the priorities that we should be taking? How do we get the organization effectively to come together to achieve the risk reduction, the threat response that you're talking about here? And so on September 21st, please join us if you can, to where we dive into that question. And I put my old McKinsey hat back on a little bit and talk about strategy. So we thank you all for joining. You will receive the slides as well as a video copy of the presentation. And we hopefully will see you on the 21st. If you have any further questions, you can drop an email to any of the three of us. Thanks so much and have a great rest of your week.